So this question is, again, asking you to use the thin lens equation to solve this problem. And of course, the thin lens equation is 1 over di plus 1 over do equals 1 over f, right? All right. So the di is the distance of what? The image. Are we given the distance of the image? No, we're asked to find the distance of the image. So that's one we have to find. So are we given do? The object is 8 centimeters high, and it's 18 centimeters from a converging lens. So it looks like do is distance of the object, which should be 18, looks like. You guys agree with that? So that's so good. We're given that. And the focal length, that's the f. It's 10. So we can start to use this equation by filling in the values that were given. So this is 18 here, and this would be 1 over 10. Okay, so that's your first step, and we want to solve now for di. So 1 over di is 1 over 10 minus 1 over 18. So we got to get this away from di, bring it over to the other side. Now here we need a common denominator, right? If you have your calculator, you could probably punch in fractions into your calculator. But how could we get a common denominator here? Is there an easy way to do that? Anybody remember? Yeah, you could just multiply 10 and 18 together to get a common denominator. And that would look something like this. So that would be 180, I guess, as the common denominator. And so 18 times 1 would be 18. And 1 times 10 would be 10. Does that look okay? So it would end up to be the 1 over di would be 8 over 180. Did you get that for an answer? And then down to a decimal or a fraction there. So what did you get for an answer there? Did anybody get about 22.5? Okay. So there's your di. 22.5 centimeters. Okay. Now, I guess I did skip a step there, though. All right. This would be 1 over 22.5, or let me just show you that step actually. Okay. So 8 over 180. I'll get my calculator out here. 8 divided by 180 is this 0.044 repeating. So 0.044 repeating. Now, if you get to this point, right, remember, take the reciprocal of both sides. And so that actually looks like this. di then is 1 over this value. And there's a function on your calculator, if you don't know, on your calculator too, even if you don't have one like mine, it's an x to the negative 1, or it would be something like that, to the negative 1. And of course, you just hit that button, it'll take that answer, it'll find the reciprocal, and let's see what happens. There we go. That's how we get the 22.5. Okay? So that's the first part. That's di. So what about hi? Well, we talked about the magnification equation. Magnification equals high over ho, or negative di over do. So we're going to focus on this part right here. And we're going to fill in all the values that we have. So an object is 8 centimeters high. So that means we have 8 in the ho part. We don't know what the high is, right? That's what we're trying to find. Negative, the di is 22.5. And the distance of the object we said was 18. So does that look good? Any mistakes there that you can see? So we multiply both sides by 8 now to get rid of this 8 right here. And so hi is, on your calculator, you just go ahead and do negative 22.5 times 8 divided by 18. And we get what? Negative 10. So the height is minus 10, and that would be in centimeters. So that means that if the object was facing upward, that means the image then is facing downward. Okay, so there's your two answers. And if we wanted to take a look at just see if this was reasonable, I suppose we could. If we just draw a little diagram here, it's a converging lens, so it looks kind of like this. And the object is 8 centimeters high. Okay, so focal length is 10. So just a quick little check here. Let's say this is the focal length, 10. The object is 18, so it's almost 2 times the focal length. It is 5 centimeters high, but it's over here, right? So what happens here? Well, the focus on the other side, the primary focus is over here. So we're going to have a ray that goes like this and then through F, right? The other one is going to come through F and then go over here. So the distance is a little bit more than the distance of the object, so that makes sense. And it's upside down. So here's our image. Just by a quick ray diagram, it looks like we should be pretty good. Line up pretty good. Okay? So you can just check the reasonability of your work that way.